Hello and welcome to GM-BIST construction. This is Benedict, your instructor. Today we are going to continue from our previous class where we stop in our advanced tutorials on modeling and analysis using PROTASTRUCTURE 2021. So I promised to show you the 3D. So this is the 3D of the structure. We are designing a semi-detached, 4-bedroom semi-detached. This is what we have. This is architectural 3D. So let me minimize. Let me go to my view. So I will say type vertical or type vertical. So you can see this is what we have. So let me see the ground floor, this is the first floor, this is your roof slab here. So we'll go to our PROTASTRUCTURE again to see it. So you can see that the columns here are not continuous. I'm going to stop at the first floor slab. So we have our cantilever beam here. So we'll also be inserting our slab over here, because this is what we have. There's a slab here, there's a slab this side, there's a slab here, there's a slab this side. So we continue now. So let me close my 3D. Okay, so this is what you have. So if you now notice, at our first floor we have a cantilever slab at both edges. So going to our second floor, our roof will now be having our beam at this place. We'll have our beam here, our beam. So at this point we'll not be putting our column here. So we also have our roof being extended to this place. These are the roof. Split it. We have the same thing this side. We'll extend it here. Extend it here. Split. Okay, so let's go back to 3D. So this is what we have. The beam we just extended for this slab here, the roof slab. So come back. So at this point I would like to introduce my column here. So let me change it to 3D. So that's whenever I insert my column, I will be able to identify where I'm trying to insert it. So we are working at the back. So I have one here, see it here. So I have another one this side, have another one this side, have one here, so I have another one here. Now, but at this point, let me try inserting here. You see what I have. You can see that we don't have a beam here, just on the slab. So if you introduce your column on your slab, there will be error when it comes to the analysis. So we'll have to remove this one. I think we are done. So let us view our 3D to see. So this is what we have. Our 3D. So we have a 3D. Okay, let us check. Yes, so what we have. So the next thing we do now is to load our beam now. So I click on one of the beam, say edit wall beam. So it's 3.47 unit weight of Nigeria blocks, and the height now will be 1.5. We'll take half of floor, and this will be 2.225. That's the size of the block. So you can copy it now. Okay, sorry. Right click, copy. So I will highlight this one, onto the back, do the same thing. I'll hold my control key, do the same thing, do the same thing, and right click, paste copy bin wall load. So okay, I'm going to paste on this one too, paste. So there's no wall load, we don't have the parapet load here. So if I want, I can actually click on here, delete wall load. I'm not going to carry the parapet bin there. Can do the same thing here. If you want, you can actually load all your bin to have your wall load. It's all depending on you as a designer, as a structural engineer, not just as a designer, as a structural engineer. If I want, I can leave this one. If I want, I can still remove the wall load. So I'm done for this floor. Let me go and check my first floor. Okay, the first floor, the bins are not loaded, so I can click on this one and say edit wall load. Weight of Nigeria block is 3.47 kilonewton per meter square. The wall height, now the wall height is the height in the architectural design minus the depth of your bin. So I will assume that in my architectural designs I have the from the DPC to my soffit or to my slab. Let me say it's 3.6. So you now say 3.6. Okay, let's use calculator. Let me teach you how to use it. I say it's 3,600 minus the depth of our bin we used was 450. So you get 3,150, which is 3.15. So and now come here and I say 3.15. Then the wall thickness given in the architectural design is 0.25, which is 225, which is 225 millimeters. When you convert it to meters, it now becomes 0.225. So I'll click on it. So in my first floor here, all the bins are carrying the wall load. So I'll now highlight on everything. I'll Control V, or you right click, say paste. Yes. So this is what we have now. So I now close this. I'll now go to my analysis, go to builder analysis. Now say analysis, then I'll go to building model check, and I'll say start. If there are errors in my modeling, this also will notify me. So building model check completed, number of errors 0. So I'm good to go now. I will now proceed to my building analysis. So let me say reselect all members. So give it time to load. So see, software is carrying out some calculations. The analysis is running now. Give it some time to process your analysis and give you the results. Do remember that in our previous class we were able to select our structural members, the type of reinforcement we want. We did our settings. So for those of you that haven't watched our previous video, you'll go back to our advanced class on structural analysis using PROTASTRUCTURE 2021, where you'll be able to know how we carry out our modeling, where we inserted our columns and how we imported our DXF file. So you can see relative story drift, satisfy limits. This is in X direction, the second one is in Y direction. All of them are passed. So okay. It's okay. So let us check our structural members. We'll go to post analysis. Let us check our columns. So this one is actually required that we increase the size. So let us check our interactive. See, so you can actually increase the size here to 450. Click on update, click on interactive design. Okay, so when we go there, we'll know how to position it very well. We also have this one here. Let's check. You can actually leave this one or this one, but for me, I would like to increase it. So we just have two members that will actually work on. We'll go to our bin. So in our bin here, we have a member that just failed. You need to update it. So when you have something like this, it's actually required that you increase the depth. So it's requiring that you increase the depth of the bin. So I can actually do it here. Or let me leave it. But when I go to my model, I know what to do. Okay. So let me check my displacement. So at the roof here, so my displacement is critical. Let me try to increase it so that I can view it proper. And displace. So just at the roof being here, I need to increase my member. Okay. Okay, so I'll come to my first floor now. I see where I have a failure. I'll click on this. I'll be able to identify this pin. Okay, this one is requiring. So I will now increase the depth. I can say 600. Yes. I have to increase this one too, because both of them are the same. I either do it here or I can use my properties to increase it. 600. So let me check my columns. I don't have issue with columns. So the column we actually work on is not our ground floor. It's at our first floor. So let us go to our first floor. Let me click. All my bin have passed. Okay, this is what we have. Okay, let me generate this member to go to my first floor. Go and replace it so that I don't have column in first floor bigger than the ones in second floor, greater than the one in the ground floor. No change. Let me try it again. Generate to this, replay existing column, so you can see it here. So this is what I will do. Let me bring my ground floor to know how the column will actually sit. So I don't have, so I'll pick it from a common point. So I will now freeze. I'll go to display. Freeze my document bin. Okay. So I'll have to now shift this column. I'll move it so that it doesn't come to the area where we have our staircase here. So I cannot generate this one to my first floor. I'll generate this one back to go and replace in the first floor. Okay. This is what we have. Okay, I will now have to change the position of this column. Let me take it to this place. Yes. Can't walk that way. I now have to change it to this place. I will delete this. Column. I will change my column arrangement now. So this one will not terminate. So that we'll have a structure that is safe. Change it here. Then yeah. Now take this one. Delete. Delete. Okay. So to be on the safer side, because I don't want to overstretch my beam, I can still split that one there. Or something like this. I don't need this one here again. Don't need this. I can take this one here now. Yes. Take this away. Take this away. Take this away. Take this away. I'll change my arrangement now because I don't want to have a 600 column as my first floor. What I do that side, I will do to the other side because they are same. Just a mirror of what is this side, that is the other. What is at the right is the same thing as what is at the left. So I can actually mirror it. Okay. Taking this one away. Taking this away. Taking this away. Taking this away. So I can even take this one away. Actually move. You can just click on this one, go to move, click here, or you delete and say do the same thing. Okay. What? Okay, this is what we now have. So I can still load back my roof beam. Let me just highlight it this way. Hold your control key, do the same thing this way. Click on this, click on this, then you now paste. Okay, so this is what I have. Now let me go to my ground floor. So I will now delete this column again. I'll put my 225 by 225 column. Take away this. Take away that. This. So let me load this bin now. Copy and paste. Okay, so let me go to my loading, load decomposition, finite elements. I will check it. In most cases, you have to run your analysis using your load decomposition method. Using your finite analysis, you try to run the analysis to ensure that all members are active before you proceed to your general analysis. So you can see it cancel. So I will now go to my finite being decomposition analysis, all stories. You can decide to highlight it, click OK, continue. Give it some time to process. You say OK. You say close. Apply to all being in the model. Apply to all being in the story model. So I can now go to my analysis, click on building analysis. If you want to check your building model, you can still check it. No error found. We are close. Now proceed to my building analysis. Reselect all members to building analysis. So give it time for software to run or to process your analysis. So your analysis is processed. Okay, this is yes. So I'll send you for the cantilever beam. Okay, your summary, everything is checked. Your relative, your stiffness is okay in both direction, x and y direction. Close. Let's check our post analysis results. Let me increase it and see all your columns. Okay, so we have another column here. It's 1, 2, 3, 4, 5, 6, 7, 8. So it's better to change this to 450. Update. Close. I already have this as 450. Now close. Let me check. So your B analysis. So we still have one B in the feed. So let us check it out. Okay, we'll work on this when we go to the model. Cancel. So let us click on this to see if there's any failure here. No failure. Let's go to second floor. Click. Okay. So this is where we have this column failing. So let us try to generate it to our first floor to see. I'll go to display. Do have a column on this side. We don't have column here. Let us delete this. Let's go back to our first floor. Okay, this is where we have a column, not at that place. Okay, so delete this one. Delete it. I'm teaching you such a way that if you have any challenge in your analysis, you'll be able to identify that place and correct your or run your analysis. So I can still go to my loading, click on loading decomposition. You allow it to process. Always ensure that your analysis have passed, all the members have passed before you proceed to any other thing, before you proceed to your detailing, before you proceed to your footing design or your type of foundation you want to design. So click on this. So okay, our model analysis, video analysis. You tend to process. You give it time to process. Okay. The stiffness in all direction of pass. So close. Post analysis. Column. Everything have passed without we increasing the size of the column. So our columns are now all Y16. We don't have Y20. Okay, we have Y20 for this, but still for Y16. So by the time you try different models, or by the time you try to rearrange your members, you discover that you have a design which is safe and which is economical. So you have to try different ways. When you try this one, maybe you have a failure, you remodel or you redesign, and at the end of the day you have something which will suit, or which a design that will not be that robust in nature, that will not be cost effective. See, all our beam have now passed. Okay, we can now go, you can see, check it here, so that I'll have a good picture of what you're actually looking at. You can see our members have passed. So now go to our first floor roof beam. So our members passed. Our columns. So this is where we're going to stop in our part 2 of our advanced class on modeling and analysis in PROTASTRUCTURE 2021. In our next video, we'll be learning how to design our footings and to also export our drawings, carry out some setting in Prota details, and we'll start our detailing in AutoCAD. Thank you. Do subscribe to our YouTube channel, like, comment, and share for others to also have access to our video to learn more and an easy way of designing or carrying out your modeling and analysis. The general arrangement, which mostly you do in your AutoCAD, you can actually do everything in your PROTASTRUCTURE. So this video is about bringing an easy and a concise way of carrying out your structural analysis for all design, be it high rise, be it high rise, be it any type of design. You can actually use this method and it will be fast for you. So I remain Benedict, your instructor from GM-BIST Construction. Thank you and have a lovely day.